Welcome to this video where I'm going to show you how to do the third part of the analysis portfolio using Yamovie. And in this part we're going to be working with regression analysis, and just to recap what we're going to do, let's look at the portfolio. Part 3, regression analysis. In this section you will conduct a regression analysis and look at the relationship between several variables. Regression analysis is used in a lot of research, and many have written their master thesis based on regression analysis. So, the linear regression analysis, which we are going to conduct, is a very, very common way of doing analysis. So, assignment 3.1, conducting and interpreting a bivariate regression analysis. The purpose of this task is to practice the conducting of a bivariate regression analysis, interpret the results, assess whether the results can be generalized to the population, and give an interpretation of R square. And what to do? Perform a bivariate regression analysis that includes your dependent variable and one of your independent variables, and interpret the constant and the regression coefficient. Can the result be generalized to the population? What does R squared tell us about the model? Yeah, and in Yamovie you do it like this: analysis, regression, linear regression. You put your dependent variable over in the dependent variable box, and the independent variables over in the covariates, and then you choose model fit and you tick off for adjusted R. And you can right click on the table to save or copy. So let's do that. Some of you might remember that I have this model or figure which is helping me to remember which variables I've chosen and how they are measured. And in this bivariate regression analysis, I'm going to, of course, use my status 1 being good at school, which is my dependent variable. And I'm also going to use skole5, which is high expectations from others to do well in school. So I'm going to see whether there's an association between the expectations from others, or the perceived expectations from others, and the perceived status of being good at school. So let's do that. We go for regression analysis. We choose linear regression, and I find status 1, which is my dependent variable. I put it over in the dependent variable, and I find skole5 or skole5, which is high expectations from others, and I put that over in covariates. And I go to this model fit, and I tick off for adjusted R. And okay, what do I find? Well, again, it's nice to have this in some way have an overview of your models or your variables, so you can more easily interpret the results. Well, if we start out by looking at adjusted R square first, which is the one we are going to comment, that says how much of the variation in the independent variable explains of the dependent variable, and this is a proportion, so we have to multiply it by 100. So 1.7% of the variation in the dependent variable is explained by the independent variable. So high expectations explain 1.7% of the variation in the social status you get from being good at school, which is not a lot. I mean, it's over 98% that is not explained. So it doesn't explain very much of the variation, though. But let's interpret the coefficients and see whether they can be generalized to the population. Let's start with skole5, which is high expectations, and as you might remember, which is you cannot see from just looking at the results. You have to know how this variable is scaled, and it goes from totally agree is equal to 1 to totally disagree is equal to 4. So that means that it's a positive coefficient. So it means that when you go one scale unit up on your independent variable, when you go from totally agree to somewhat agree, the the depend variable increases with 0.141 scale units. So the less of a pressure you feel, from others, or expectations from others, the less you think that being good at school is increasing your social status. So less expectations, the less you think, the less expectations you feel, the less you think that it increases your social status to being good at school. And as you might notice, I have a bit of a hard time or kind of interpreting this, because it's much easier if a high value goes together with a positive statement. So it would be much easier if totally agree was equal to 4 or 3, and I would set totally disagree to 0. So I would have I would go from for example 0 to 3, and 0 would be totally disagree, and 4 would be totally agree, and the same for this one, that reduce your social status a lot would be 0, and increase your social status a lot would be 4. So I'm going to show you how to do that in the next step, and it will be so much easier to interpret the results. But you interpret all regression results as when you go one scale unit up on the independent variable, this is the increase or decrease, if it was a negative coefficient, in your dependent variable. And it can be generalized to the population because it's significant. It's way below 5%. And the intercept, that is the constant. Again, I would like to have to interpret this substantially. You should 0 should be a substantial value on the independent variable, but it's not, because this is the mean score on the dependent variable for everyone who has the value 0 on the independent variable. And as you can see there, 0 is not a value on school 5 or school 5 high expectations, so it's not actually possible to interpret this in a meaningful way. But let's assume that 0 is equal to totally agree, that they is equal to totally agree, and that is that you have a lot of expectations. Well, for those who say totally agree, if that was 0, then that this would be their mean score on the dependent variable, and that's equal to 2, which is increase your social status a bit. So then we would assume that this would be the value on the dependent variable for everyone who has 0 on the independent variable, and that would be increase your social status a bit, because it's closer. It's much closer to 2 than 3, for example. So we would say that on mean, they say that that for those who totally agree that they have a lot of high expectations from others, they would be on mean, saying that it increases your social status a bit to be good at school. However, as I said, 0 is not a substantial value, so we cannot interpret the constant substantially. So we'll be doing that in the next part, and that is in the next part, which is recoding of variables for multivariate regression analysis. The purpose of this task is to practice recoding of variables and to construct dummy variables that will be used in the multivariate regression analysis in 3.3. What to do before you can go ahead and carry out the multivariate regression analysis? You must recode all your non-scaled independent variables into dummy variables. I only have one. I only have gender. So I will do that to gender as I did in part 2, but I haven't saved it from part 2, so I will do it again. Use either the lowest or the highest value on the variables as the reference category that is equal to 0, or select a reference category equal to 0 that is meaningful to you when interpreting the regression coefficients for the dummy variables included in your model. And you do it like this: data compute variable, provide a name for your variable, that's your new variable, and then functions, you choose logical, and then the if statements. And if you want to do with gender, which is kjønn in Norwegian, you have to do it like this. So you say if you have 1 on the old variable, you should have 1 on the new variable, and everyone should have 0. So yeah. And next, you need to consider whether to reverse the scaling on 1 or more of your scaled variables. Note that in order to be able to more easily interpret the regression results, it's an advantage if a high numerical value coincides with a positive statement. Example 4 equal strongly agree, while a low numerical value coincide with a negative statement. Example 0 is strongly disagree. And you also do this with a compute function. However, you subtract, for example, you use status 1, you subtract with 5 because it's a 5 scale variable, and to reverse that, you subtract with 1, and then it will go from 0 to 4. If you have a 4 scale variable, you must subtract using the value 4. So, okay. Again, I take a look at my my model or this model of mine. You can have this in any form you would like, but it's really nice to have a overview of how things are looking. So you can so you know which variables you have included and how they are measured. So okay, so I will do to gender. I will do this into a dummy. Age, which is klasse, which is school level, or which class they go to. That it's 8 year is 1, 9 year is 2. So this makes sense. For this school 5, I have to reverse. School 7, school works on the weekend, I have to reverse. This one, getting drunk, I have to reverse, and also the status 1. So a low value will go together with a negative statement, and the high value will go with a positive statement. And I will also make sure that all starts at 0. So so 0 is a substantial, meaningful value on all the variables. Okay, let's do that. We can then, we then have to go to data, and I have to start with first start with gender, which is kjønn in Norwegian, and then I choose compute, and I say call this for gender dummy, and then I go to the functions, and I find logical, and I choose kjønn, double click, and I say if you have to have 2 equals, old value 1, then new value 1, and everyone else 0. And then you see that girls are set to 0, boys are set to 1. I can also change this. If I want girls to be 1 and boys to be 0, I just do like this, and then you can see that it changes. So girls are 1 and boys are 0. Okay, and then I have to take school 5, which is high expectations, and school 7, which is schoolwork on the weekends. And I want to compute, I want to transform, make a new variable of that as well. And I can call that for school 5, rev for reversed. And I then take, and I know that this is a 4 scaled variable, so I have to subtract by 4 minus fem, and then you'll see I get a new variable where we have one somewhat disagreed. Let's find totally disagree. Totally disagree is 0, and somewhat disagree is 1. So this is now reversed, going from high to low. And then I have school 7, which I also want to compute or reverse, so I call that for school 7 reversed, and then I just take 5 sorry, 4, because this is also 4, minus school 7. And I also get this. Total degree is the highest value, is 3, and then total disagree is 0. So this goes from 0 to 3, and is still 4 scale, but it's reversed. And then I have to take status 1 and status 3. My dependent variable status 1, which is there, and then I compute, and I call this status 1 reversed, and this is a 5 scaled, so I have to take 5 minus status 1, and status 3 is also 5 scaled. I can see that from looking at here, if I wonder, and then I take compute, and I take status this 3 reversed, and I say 5 minus status 3, and I do like that. Yes. Okay. So then I recoded all the variables. Okay, so now I have recoded all my variables, and I want to do the multivariate regression analysis. And let's look at what the portfolio says about doing the multivariate analysis. Well, conducting and interpreting multivariate regression analysis. Why? The purpose of this task is to practice the conducting of a stepwise multivariate regression analysis, interpret the results, assess whether they can be generalized to the population, and give an interpretation of R square. And perform 3 or more regression analysis where you build on model 3.1, interpret your independent variables in a stepwise regression. For each model, interpret the constant and the regression coefficient. Can the results be generalized to the population? What does R square tell about the model? Do you discover changes in any of the regression coefficients between different models that arouse your interest? And you do it like this in a movie. I'm going to show you how you do it. Okay. So again, I have this this model, and I'm going to first include the high expectations, and looking at that, the reversed one of that, and the reversed one of the social status you get from being good at school. And then I'm going to include in my second model schoolwork on the weekends, and in my third model I'm going to get the status of being drunk, gender, and age. That's going to be my 3 models. So what do? Well, I go to regression, I go to linear regression, and first of all I can, on the model fit, I can just tick off adjusted R square right away, and I can find status 1 reversed, put that over in the dependent variable, and then I have skole 5 reversed, I put that over in the covariates, and then I wanted skole 7 because I want that in my second model. I put all over in the covariates first before I start building models, and then I have gender the dummy, and I have age. No, yeah, that's called klasse, which is the age. I just put over that, and then I also have I put that over in the deep end. That should be there. I have to status owner is that. So yeah, I can do like this. You can change between them if you want to do like you're just dragging them down. And then I have status 3 reversed there. Okay, so, and I want to have a model. I want 3 models. So I have now everyone is in the first block. So I have to add 3 other blocks, and I want this working on the school on the weekends. I want that in the second block, and I want these other gender dummy and the status you get from being drunk. I want that in the third block. So I just drag them down there. Okay, so I can first start out by looking at the adjusted R square, and I can see that as for the bivariate regression analysis, the high expectations explain 1.7% of the variation in the social status you get from being or the social status you get from being good at school. So high expectations explain some, but not very much. When you add working in the weekends with schoolwork, it increases with 2.2 or 2.26%. So it explains a bit more, but not a whole lot more. And when one includes the social status from being drunk, age, and gender, you explain almost 6% of the variation in the social status you get from being good at school. But it's 94%, almost 94% that is, or more than 94% that is not explained. So there's still a lot of variation that we don't explain. But we can, using this model-specific results, we can first start out by model 1 and looking at the results. We see that now a low value goes together with a negative statement, and a high value goes together with a positive statement. So when you go 1 up on school 5, school FM, school 5, which is high expectations. When you increase with 1 scale unit on expectations, the dependent variable increases with 0.142 scale units, meaning that the higher expectations, the more you think that it gives you a higher social status to be good at school. So those who have the higher the expectations people feel from others, the more they also perceive that being good at school is something that increases your social status, and 1 scale unit up on high expectations increases the dependent variable with 0.142 scale units. And this can be generalized to the population because it's significant. The intercept, the constant that is in this first model, is 2.2. That means that they say that for those who say that they don't who has 0 on high expectations, that means that they don't. I can look at my model again, and that means I've turned it around. So it means that they 0 is totally disagree. So those who totally disagree, they score 2 on the new variable, which means that it actually say that it reduces your social status a bit, because this is it goes from 0, and this is 1 now, and 2. It doesn't make a difference. So in this model, actually, those who say that they don't feel any pressure at all, they score 2 on the value 2 on the dependent variable, which means that they don't think that being good at school doesn't affect your social status at all. So that's the interpretation of the constant in this model. Let's look at model 2. It doesn't change much, the intercept is actually, or the constant is getting closer to 2, because these are the people. This is the value on the dependent variable for those who say that they don't feel any pressure and they don't work at school in the weekends at all. So it's getting even closer to 2, which is that it doesn't have any being good at school doesn't affect your social status at all. And as you go 1 scale unit up on feeling higher expectations from others, the dependent variable increases by 0.1332 scale units. So higher expectations goes together with higher perceived or feeling that or meaning that you get more social status from being good at school. And we're also, the more you are agree to the statement that you work with school on the weekends, the more you also perceive that the social status of being good at school is or being good at school is important for your social status. So when you go one scale unit up on yes, working with the school in the weekends, the dependent variable increases by 0.035 scale units. So yeah, and again, this can be generalized to the population because it's significant. Let's look at model 3. Gender is significant, and as you might remember, girls are 1 and boys are 2. So when we go from looking at boys to looking at girls, on average, the perceived social status of being good at school, or how much being good at school affects your social status, when you go from looking at boys to looking at girls, it actually decreases by 0.0495 scale units. So going from boys to looking at girls, compared to boys, on average means that you don't get as much social status from being good at school as boys. Boys are more inclined to say that it actually increases your social status, being good at school. The same with and with age, it's the other way around. The older kids feels that that you get a higher status from being good at school than the younger kids. When you go from looking at the 8th grader to a 9th grader, the perceived social status of being good at school increases with 0.049 scale units. So that is when you go one scale unit up on the class or age, it increases your social status from being good at school increases with 0.049 scale units. And for those who think that it increases your social status of getting drunk, the one scale unit up on yes, it increases your social status getting drunk. The dependent variable decreases with 0.1322 scale units. That meaning that the more you perceive that getting drunk increases your social status, the less you feel that it increases your social status to be good at school. And all these coefficients are significant, so they can be generalized to the population. And to interpret the intercept, this is the mean value on the dependent variable for everyone who has the value 0 on the independent variable. So it's those who feel no pressure, those who don't work in the weekends, those who are for girls and in 8th graders, and who do not think that it increases your social status to get drunk. So this is the mean score, meaning, and it's 2, so it's meaning that it doesn't affect your social status for boys, 8th graders who don't think it's very cool to get drunk, who don't who don't work with school in the weekends, and who don't feel a lot of pressure doing to work with doing well at school. So okay, that was part 3 of the analysis portfolio, doing multivariate analysis, regression analysis.